Right, morning everyone. How are we all doing? You ready for the second day of NDC? Right, my name is Sandeep, and today we're going to have a look at building real-time APIs with GraphQL. Before we have a look at what we're going to cover today and the agenda, I just want a quick couple of questions, just to kind of get a gauge of where we are in the room. Has anyone not heard of GraphQL before coming to this conference? One? That's pretty good. Two? Not too bad. Okay, so is anyone using it or had a play around with it? Anyone using it in production? Wow, that's pretty good. It's impressive. Usually there's no hands. Awesome. So let's have a look at the agenda. So this talk is essentially split into two. So the first half we're going to have a look at what GraphQL is, what problems it solves, how to build a GraphQL server, and then look at some of the core concepts. And the second half, we'll kind of look at the real-time aspect of GraphQL and how subscriptions fits into the landscape when you're building these real-time APIs. So let's start with the ultimate question. What is GraphQL? Well, essentially, GraphQL at its core is a query language for your API. It gets confused a lot with being a database language because of the QL, and people think it's like SQL, but it's actually not. It's actually a query language for APIs. So what do we mean by a query language for APIs? Well, here's an example. So with GraphQL, you essentially describe your data, which is basically your API domain, and you do this via the type system that's built into GraphQL. And then you can query GraphQL to ask for a specific set of data. So in the middle we have a query, and we're querying for some patient information, its name, and there's an identifier with some arbitrary string. And at the right is the response. And the most important thing about this example ultimately is that the query matches the same shape as the response. And this all happens in one single network request from client to server. And that's essentially what GraphQL is at its core. So GraphQL is built on a spec, and it's a standard. So it's not limited to JavaScript. The demos that I'm going to do are in JavaScript, but there's Sangria, which is a Scala framework, which is a very popular one, which is one of the first actual implementations. There's one in .NET, there's one in Java, there's one in pretty much every language that you can think of. And GraphQL is hierarchical in the sense that you have an object graph and nested associations with that. It's client-driven in the sense the client dictates the shape of the query, and basically that's what they get back in their response. So it's kind of like client-driven development. A lot of the stuff has moved from the server down to the client. And GraphQL comes with a type system, so it's strongly typed. And each GraphQL server has its own specific application-specific type system. So why does GraphQL exist? It's a good question, because there's various other technologies. When you're building APIs, there's SOAP, there's REST, there's multiple different ones. So if we think about when we're building APIs today, and we think about all the challenges we face, because now there's a lot of mobile devices, there's multiple platforms, and everything needs to be efficient and work on low bandwidth networks, ultimately. So we have things like efficiency, is along the lines of how much data are we actually getting back, how many requests does it take to get our data. Then we've got things around predictability. Do we expect the data back in the same shape? Is it what we actually asked for? Then we have versioning, and if you think about versioning, there's various different ways you can do versioning. Ultimately, if you can, you'd stick to evolution, but you'll see stuff in the headers and you'll see stuff against the URI. There's caching. How do we do caching? What is it? We're using a network layer. Do we have network caching at all? Or are we using the application server to do our caching for us? And then we've got things around security, tooling, documentation, and various other things. So as you can see, there's quite a big list, and this is not really all of it. And these are the kind of things that we have to think about when we're building APIs. So let's have a look at an example. Do we have any Game of Thrones fans? Woohoo! I've got to be honest, I've only just started binge watching it, so you're probably all ahead of me on this one. But this is an example of a screen where we have three components. So in the middle we have like a character's little bit of information, so it's Jon Snow and it's a little bit of gender, and there's culture, and where there's born. And then we have allegiances, and then we have the books that they've actually appeared in. So essentially we've got three components here. So interestingly enough, does anyone know about this API? Iron Ice and Fire? It's basically not a GraphQL one, but it's a REST API that tells you everything about Game of Thrones. So there's 3 endpoints. There's books, characters, and houses. So if we think back to our example, for our character information, I'm going to use Jon Snow as our character. So here's our URL, and this is the data that's actually returned. If we have a look at the payload in itself, there's a lot of data there. And if you think back to our screen, we don't really have that much data. So this is a concept that we call overfetching, and it's when we're getting too much data from the server, and we only need a small part of it. And this is not really good if you want to build efficient APIs, because a lot of this stuff will just go to waste, and it's going to cost people's bandwidth either way. So we have the characters, but interestingly enough, we have the books that appear in and the allegiances. So if we have a look, the allegiances is actually another URL that we have to go to get this information. We don't actually know what this information actually looks like. We know that this is how we get to it, but we don't have an example of, say, does it contain the book's title, author, and so on. And this is a concept that we call underfetching. It's where we don't get enough information that we need, and then we have to make subsequent requests to the server to get it back. Now, this is very common if you're using the hypermedia constraint of REST. The better you get at implementing that, the more this happens, because you deal with state transitions more often. So if we think back, we've got 3 potentially calls that we've got to make for our data. We've got the books, and then we've got the houses. So that's not exactly the best kind of user experience. It's got to go over and make multiple calls. So there's ways to solve this. So if we think about the URL, we could do an includes. So depending on which framework you use, or if you roll your own for your hypermedia constraint, you can have something called data inclusion, where I could say, okay, give me the books as well as the allegiances. Now that kind of, my spelling's terrible, but that kind of gets around this problem. But at the same point, you still have a problem of overfetching, and you can add fields in. You can have spatial field sets, which allows you to do this. So there's another mechanism that you can use, but there's no real standard. There's various ways you can do it. There's HAL, there's Siren, there's probably a few other ones if you've used, made a REST API before with a hypermedia constraint implemented. So it's kind of like, it's a bit difficult. So if we think about this and how we could actually change this, and how would this work from a GraphQL perspective? Well, actually, for this API, there's actually a GraphQL version. So this is not GraphQL. This is called Graphical. So this is an IDE that sits next to your endpoint. It comes with all implementations, and it basically allows you to run queries against your GraphQL server. On the right, we have some documentation, which is basically all the types that are in the system, which we kind of briefly mentioned at the start. And we have, this is how we can query stuff. So if we now think back to how we wanted to get our data, character 583 is Jon Snow's ID. Actually, that makes it a little bit bigger. And we can see, we can actually have these nested objects on the left for the allegiance connection and the book connection, and we can get all this information in one request. But secondly, we can get only the information that we need. So for our screen, we don't have to overfetch, and we don't underfetch either. So this is a good example of of 2 APIs that exist. They're both public. They're open source. You can view them in your own time if you're interested. So yes, this is kind of, it highlights the fact of what GraphQL is. So if I run this query, I just want to point out something interesting that happens over the network. Let's increase this as well. Is that can everyone see the bottom, or is it a bit too small? Because I can make it bigger. So if you look at the bottom, this is actually how GraphQL works. Just a little bit of context is that it actually posts to your GraphQL server. So this sits side by side, and you can see that there is in the actual body in the payload we have the query, which is what we're interested in, and then we have some variables. So I just wanted to give you that just for a little bit of context, because we're going to see that more in action lately. So now, GraphQL solves ultimately the efficiency issue that we have. It helps a lot with it. So you can think of GraphQL as this translation layer that sits in front of your business logic or your services behind, and it's a single point of truth, so you don't have multiple endpoints, and if you want to extend it, you can add objects to your graph, and that's how you go forward with it. And so the difference now that each channel, so we've got mobile, desktop, they can get their data they need in their shape and however they feel fit. There's no custom endpoints. I don't have to include anything on the queries. There's nothing I have to do extra as a developer. And now, as you can see, you can actually solve these in REST. I'm not saying you can't, but the thing with GraphQL, it's an opinionated set of packages which does this for you. So it kind of wraps a lot of this logic up. So if you're interested, then that's one of the use cases of it. So what about versioning? So I haven't really talked much about versioning in terms of GraphQL, because GraphQL doesn't really, it says in one of the best practices is not to version your API. So what it allows you to do is it forces you to follow the evolution. And what we mean by that is, over time, we will add new fields to our API, and then we'll deprecate old fields, and then once these deprecated old fields are no longer in use, we can remove them. And so ultimately, we're not going to break our contract or our queries that people are running against the API. So there's a special directive, this is called. So this is a type, and we have this deprecate directive. And what this actually means is that new clients will actually see this in terms of when they query. So with the intelligence of GraphQL, they won't actually see this, but existing clients will. So the power of having this attribute, or directive as it's called, is that you can monitor usage of the query. So a query comes in, and you can inspect the actual payload that comes in of what the query is, and you can say, okay, they keep using this deprecate field, and you know which client's using it because you know which client is calling it. So over time, it becomes very easy to manage, and this is one of the real plus points about having something like this. It's kind of baked in. So that's how it helps with versioning. So what about the tooling and developer experience? Because ultimately, as developers, the developer experience is very important. We don't want tools that either slow us down or make us do extra work, and we can achieve it with other technology in a simpler manner. So GraphQL is built on something called introspection. So if you think back to the graphical editor that we saw, the ID, that is built because of introspection. So because of introspection, you can build tools. And what we mean by introspection is, if there's any .NET developers who've heard of reflection, it's essentially like reflection of your types. It can understand the whole schema. So you can query everything, the whole structure, what operations you can do, what queries they are, what types of the fields, are they strings, are they booleans, so on and so forth. So this is really, really good for building tools. So as you saw, GraphQL was built like that, but you also get things like autocomplete, and you can validate at compile time because you know what the schema is. So one of the important things is code generation. Because you can query the schema, imagine you're using the C# implementation. You could query your GraphQL endpoint and generate types off the back of this. You could generate C# classes because you know what all the types are and what the fields are. It's the same we can do with TypeScript. So there's actually a code generation package that is available. It's in the resource at the end. If anyone's interested, I can talk you through that. There's one for various different languages. And also, we briefly saw the documentation. And you get documentation for free, but there's a caveat to this documentation. Ultimately, this documentation is good for developers. It allows you to inspect the types and so on and so forth, but it doesn't take away the fact about proper documentation for your API. It's often confused with that it says it gives you this documentation, which is fine, but it doesn't tell you, in this documentation, you're not going to put things about rate limits and what the usage of these APIs and explanations about how to do authorization and authentication and so on and so forth. So this is really good for developers, and you can add descriptions to your actual types, but it doesn't take away the fact that you need proper documentation. So now we've got an understanding of what GraphQL actually is and what it kind of aims to solve. Then I just want to look at some of the core concepts before we build actual GraphQL server. So I've actually broken these down into 3 different areas. So we have a type system, and we have a schema, and we have a query language. So the type system is a way we define our domain. It's essentially, we can define these types in this schema definition language, is what it's actually called. And if the first part is a type, that's how we donate it, and then we give it a name. And as you can see, there's various fields in this type, and they all have a value in sense that their fields have a type. So you can have ID as a special field, which is essentially like your primary key, and you have string, and then medications is one that I've put in myself, and then you have boolean, and you can make your own scalar types as well. So it's not limited just to the ones that are already built in. And there's various, if you're using JavaScript, there's various packages in NPM for like dates and extra ones, because it doesn't give you a date one out of the box. So if our type system defines our data model, our schema then defines how we can query our graph. That's ultimately what the schema is. It's a specific entry point into the way that we can query. And if you look at the top, we have a query, and it says basically we have a patient, and we've passed it a variable, so we have ID, and it's an integer, and it's going to return type patient. And then we have this schema property which says basically it has it's 3 root values, but mandatory one is query. So any GraphQL server that you build has to have a query as its root type, but there's other ones such as mutations, subscriptions, but they're optional, but the actual query is mandatory. So what the schema actually gives you, it gives you a contract between your client and your server ultimately. It exposes the capabilities of your API, and that's essentially what a schema does. So we've got a type system where we define our actual structure of our data and how we model it, and we've got a schema of saying how can we actually query this data and what can we actually do with this API. So where do you actually get any data out of this? So how does that magical piece come to play? So there's something called resolvers, and resolvers, each field on one of the types has a resolver, and resolvers are just basically where you can run arbitrary code. It has 3 parameters. There's the object, which is the parent object, and there's some arguments, which we will see what they're used for, and the same with the context object. I'll go into that in the demo in a little bit more detail. But ultimately, this is where you actually say, okay, go to my database, go to my API, go do any mapping that you want. This is essentially the core of it. So that's how essentially GraphQL works. You have your type, and then you can resolve each type, and then you have a schema which says, okay, this is how we can actually query and what operations that we can do. So the query language as a whole is the core of what GraphQL is. So there's 3 operation types. One is queries, which we've seen, which we can send a query and it'll return some data back. Mutations allow us to write data, but you always have to have a return type when you write a mutation, so it reads data as well. And then subscriptions is one we're going to see a little bit later on, which allows you to build these real-time event-driven systems. There's some other key features about the query language which are pretty cool. You can have aliases, so you can run multiple nested queries in one query block. So for example, with our Jon Snow in the graphical, we're just searching for Jon Snow, but actually if we alias that and then search for another character with a different ID, you can run all that in one request, and it comes basically in the same shape that you asked for, which is really good. And there's fragments, and fragments we'll see in the demo as well. Ultimately, what fragments allow you to do, if you have an application where you're building a bunch of components and you'll have a lot of queries which are similar, and you get a lot of queries which have similar fields in them, like say a patient has name and you're referencing that in many places, fragments allow you to snap that bit of logic out and share it across the basically all queries, so you get away with duplication. So it's really useful for that. So now we've got like an example of the core concepts. Let's actually dive into building something useful. So for some context, I'm just going to, I don't think I can increase the font on this one, but I'll go through it. So the context that we're actually going to build is an electronic patient record system. So we're going to have a patient view, which has some information about the patient, so some summary information and some information about the medications that they're on, and some information around their current encounter. And then we're going to have a list view that shows patients on a specific ward. And this is the database structure for it. I've already preloaded it with some data. So let's get started. So this is the structure of our application. I'll make it a little bit bigger. So there's a client. It's an Angular client. It's just, I think it's using Angular 4 from what I remember. And in application, we have various components. I'm using Apollo client, which we'll talk about a client for GraphQL APIs a little bit shortly. And then we have our server, which is basically our GraphQL server. So this kind of structure, you have like a server file which loads and starts your API, and then you have your GraphQL schema, which is currently empty, and we have separated our resolvers, so it's basically easy to manage. So as we go through this, I'll explain more about the structure of this, because having built quite a lot of APIs for GraphQL, I found this sort of pattern and this sort of structure very easy to kind of work with, and it allows you to unit test stuff, and if you're working in a fairly big team, it's easy to manage. So the first thing that we want to do is, I've installed all the packages already because of flaky internet connections usually, so I've just done all that up front. So I've imported all the basically dependencies. There's GraphQL, GraphQL Express. So the first thing that we want to do is basically make it run. So all we're doing here is we're just saying when we get to the /graphical or GraphQL endpoint, we pass in our schema, and that's really about it. And then we're setting the endpoint up for graphical. So if you do /graphical, that's what you're going to get with that ID. So the first thing that we want to do is actually add in our schema. So we're going to use the schema definition language. If you've seen online, there's various ways. There's ultimately two ways that you can do this. There's an object type version and there's schema definition language. By default, if you can, use a schema definition language because one, it's very readable and it's very easy to snap out into smaller components. And secondly, it was designed initially by the initial reference implementation designed the object graph types that you saw in JavaScript just to get the project out ultimately. But the schema definition language is, I would advise you to, if you can, use that. I haven't found any differences in either of them, using both, and there's no real limitations. So what we have here is we have a type, and then we have an ID, patient ID. It's got some fields on here. It supports enums, so I've got an enum here. And to add comments, you just put a hash, and that'll come in the documentation. And we've got one query here, which says, basically get the patient, pass in an identifier. The exclamation mark stands for it's mandatory. And the return type is a patient, and this is just what we're passing into our schema. So now we've defined our type and our schema, all we've got left to do is add in the resolver. So how are we going to get this data? So this is the interesting bit. So as you can see, hopefully, let's make it a little bit bigger. As you can see, all I've got here is a plain JavaScript object. I'm not calling an API, I'm not calling a database, I'm not doing anything. Like I said, you can just run arbitrary code in here. This is all resolvers are. So there's three parameters. There's object, which is a parent object, and we'll see that when we have nested associations. Arguments is, we'll pass in the arguments of the query. So we said a patient ID, I'll pass that in, that'll be a property on that. And then we have this context object, which is a special object, which is passed every time we make a request. So if you want to pass in something like the viewer or the authentication token or things like that, that's where you store that information, and that's passed on every request. So ultimately, all we have here is just basically a plain object. So we've done everything apart from actually map these resolvers. So when you use this schema definition language, you have to provide the implementation. So if we step back and go into the schema, so there's a tool called GraphQL Tools, and it basically makes your schema for you in this make executable schema. So we pass in the schema which we defined, which was a GraphQL file, and we pass in the resolvers. And the resolvers we have defined for patient, and this is a resolver mapper we call. So this literally maps to your query. So you can see it's got the same name, patient. So actually what does it, when it's actually run and makes it executable, it basically matches it on name. And because with enums, generally you can have either a strings of value or you can have them as numbers. You can put them on the root type of your resolver because they're not actually in your, they're not assigned to a query or anything. So that's how that will reference that. So in our database it might be 0, it might be 1, and that's what the field we expect. So if we run that, and then go back and close these. So here's our API, and if we make a basic call now, we can see we get back the data, which is just basically hard-coded. And ultimately, that's all GraphQL is. That's, if you understand that, you've pretty much grasped all of what it is. It's pretty much rinse and repeat. It's very similar for mutations. It's very similar for adding in like a database or a backend, which we're going to do now. But this is a core principle. This is a very simple way to stand up an API. So if you're interested in building stuff in for rapid development, it's really, really quick to stand up like a fake endpoint. So this is definitely a real neat way of doing it. So next, let's make it a little bit more meaningful and actually read from a database. So we're using SQLite in this application. So the first thing we want to do is add in just a query. So all we're doing is reading from the database and we're passing in the ID. These are just some helper methods at the top, which we'll see used a little bit later. So that's our database, and ultimately, resolvers should be kept small, and they shouldn't really directly, I don't think, talk to the database in the sense you shouldn't pass a context to it. You should have an intermediary. So a good way is having models, and these models act as your kind of controller between it, like a mediator. So in patient now, we can add basically all we're adding is a new class, and it's got some information how you can construct a patient, and it's got a static method, and we're getting by ID. So now what we need to do, we need to actually update our resolver to call this. So as you can see, we're passing it actually in on the context now. So it's context.patient.get by identifier. So if we go back to our server, we actually have to pass that in our schema for every request, and we'll see that. So what we're doing here, on every request, it will pass this context object in, and we're just basically creating a new object and passing in our model for patient. So now if we go back to our application, if I just quickly set up the database. So all we're doing here is we're just opening a connection to our SQL-like database and then starting the application. And so if we go back, now if I run this, it's actually, let's see this, change this query slightly. So that's the first record on the database is John Snow. And that's essentially how you can work with databases. It's fairly simple, it's fairly trivial. If you wanted to, in your model, change that actual static method that we call to get the patient, you could call an API at that point. You could just have static data. You can pretty much do anything. It's literally, as long as the data returned is in the shape that it expects it, then generally that's all you have to do. So what about nested associations? Because for this example, we have basically just a patient field, but we don't have anything that's related to the patient. So a patient in our system will have medications, and it will have an admission as well, because they're an inpatient. So if we go back, the first thing that we'll do is we'll add, nope, wrong file. So all we've done here is now we have two new fields on our patient. One is medications, and there's a new type for medication, which has some fields on it. And then we have an admission, which has some more fields on it. And the square brackets are essentially mean that this is a list, and we have an argument that we're passing in. We're going to limit this to not get all the information we can pass in. We can get 1, 2, 3, or maybe get 10, depending on what we want. So now we defined our type. Let's actually do what I said I was going to do, add a query to get this out of the information out of the database. So now all I've done is basically add a way that we're going to read out of the database to get the patient admission and the medications. And what I'm actually going to do is I'm going to add a new model in for the medication, and this is how we return it. This is the method we're going to use. And I'll do the same for admission. And now, if we go back to our resolvers, we need to resolve these. So let's remove this. So we've added in 2 more resolvers. We've got one for medications and one for admission. And basically these are on the context, and this is how we get them. But we have to still provide for our resolver mapper now. So this is where some magic happens, and it's interesting to know what happens actually here. So previously we had our query, and our query matches our schema, and it says it's got patient. But as you can see, there is a patient, and it's got medications and admission. So the way this resolver mapper works is, because on our patient schema we had medications and admissions as fields, to access those fields when it actually resolving them to find out what the types are, then we have to map them. So ultimately this is going to, when it runs in the actual schema, it'll be patient.medications. So that's why we have an object that says patient, and then we have medications and admission, and the names match, and that's how it kind of works out which of your types to resolve. It's pretty clever, but it seems like a little bit of magic, but once you get it, it makes a lot of sense. So now we've added that in, we've just ultimately got one more thing to do. We have to pass our new models into the context so we get access to them. So if we build that, and now go back, if we clear this, now if we run this query, you can see that we have some medications for a patient, and we have an admission as well. And that's how you work with nested association. So I'm passing in a limit of 5. So just to test if this actually works, I'll pass in 1. And you can see, it'll just limit that. So that's how you can do things like, if you want to limit like the number of information that's brought back, you can and do paging. That's how you pass in variables, and that's how you structure it. So we've got this API now, but what would this look like from a UI perspective, and how do we hook a GraphQL API to basically a UI? So if we go back to our code base, actually firstly, just to save a little bit of time, we're going to switch branches. And start again. So all I've done here is just switch to a more up-to-date branch, and because we've seen how queries are done, I've actually added in a ward query now to show us like a ward view. So if we go back to our schema, we actually have a new ward type, and we have a new way to get this ward, and basically pass in a ward code. And then if we just look at our resolver, we now have a way to get ward here, and then this is how we do the mapping of the patients. So if we just double check that all works, and there we have a ward view. So now we can actually have a look at the UI. So this is just a very simple Angular application. It's using Apollo Client. So a little bit about clients. The first thing about clients is, if you're using GraphQL, don't roll your own. The problems that you're going to solve have already been solved. There's Apollo and there's Relay, the two big ones. If you're interested in React and you're going down that pathway, you should definitely look into Relay. It might be part of your actual project. It might work well. But generally, Apollo Client works with React, it works with Angular, it works with all of them. It's not specific. And basically, there's an iOS version as well. But clients as a whole allow you to query GraphQL APIs in a very simple way. They give you convenience methods to query, mutate, and do things like subscriptions. But also, one of the problems with GraphQL is its caching. So instead of solving the caching yourself, the client does a lot of this caching for you. It basically gives you a normalized cache, which is essentially, if you query the patient 5 times, it'll only be stored in the store once. It's just a flattened structure of the data. I'll show you that in the UI, because there's a Chrome plugin called Apollo. Can't remember what the second part of it is, but that shows you the store and it shows you the cache, so it's very useful when you're debugging and when you want to run queries in the browser. So that's a little bit about clients. So all we're doing with this client is we're pointing it to our GraphQL endpoint, and we're basically adding a network interface, and we're just going to inject this into our constructors where we're going to use it. So before we do that, let's have a look at some of the queries. So GraphQL tag is just a way of writing a query. It gives you an abstract syntax tree, and we can then pass this to actually our method to query. So interestingly enough, we were talking about fragments. So here's an example of a fragment. So I've defined a fragment with patient, first name, surname, birthday, identifier, and gender. And because we're using this information in various places, I can use a spread operator to basically expand, and it'll basically choose these fields, because on the ward view we have a list of patients and their information, and on the patient summary we'll have the same sort of information. So instead of duplication, you can use fragments to do it. They're very useful for this sort of stuff. And let's have a look at this actually from a UI perspective and see if it's running. So in our ward view, we should have a way to query. So all it's doing is the Apollo client's passed in. We're using a watch query, and the ward query is what I just showed you. And the variables, it's taking the ID from the URL, and it's passing this in as a ward code. And then once we get some information, we'll get the ward, and we'll get the ward patients back. So now if I go back to the UI and see. So we've made one query there here to get the actual patients on a ward. And then if we click through, we can see there's a little bit of information about a patient. But the interesting part is I was saying about this plugin, is that if you have a look here in Apollo, you can actually run queries. And if you look at what's actually in the store is a cache of what we've actually made a query about. So this is a very useful set of tools that you can use especially when you're doing development and debugging, so you can run queries. It says what queries that you actually run. There's no mutations because you haven't run any, but it gives you this inline graphical editor that you can query instead of having your own one up and running. So it's definitely useful if you're debugging, because it saves a lot of time when you're looking what the state of the store is. So let's go back to our application. So we've seen that we've now got a UI and we have a decent understanding of what queries are. So let's have a look at what mutations are. So in our system, an example of a mutation would be we want to discharge a patient and they want to be basically off a ward. Queries and mutations are very similar in that sense. They'll have a resolve function. The thing about mutations are that you will always return data back, and this could be a simple value for an integer or it could be a complex type. So let's have a look at this. So in our schema, we need to define what this is going to look like. So all we have here is an input object. So the main difference between queries and mutations is that we can pass this input object in, which is like a complex type, instead of having single variables. And this is useful when you can add other fields with other complex types that you've created yourself. And it's a really neat way of passing all the information basically on one property. And what we're doing is we're returning this payload called discharge patient payload. And it's essentially just a little bit of information about the patient. Just below. So something that you might want to consider when you're doing this is not directly returning the patient information straight away, in the sense that assigning the mutation to the patient. Because if you put a class, or type in this case, like payload in, you can add custom properties on, like if there's any errors. And if you think about how you're going to evolve your API over time, it's very easy to work with a structure like that because you can do additions easily. If you fix it to the patient type, then you're kind of stuck with that. You can't pass any extra information at that point. So it's just a little bit of hindsight. It's kind of having a look at it and having a separate object always return. Now in this scenario, for our payload, we could have a field which is a patient. We could return the patient type in that, and then we can have a user errors field and various other ones. But I would always try to structure it without returning the same type as the normal query does. And ultimately, don't return just a single value like an int or a bool. I know some people recommend it, but again, you're in that same scenario that if you do that, you are fixed for that over time. Once you change that, you're going to break someone's implementation. And the whole point of GraphQL is it's supposed to evolve. We don't want to kind of snap people's implementations which they're currently using in the wild and start having different versions. So we've added our mutation into our schema. So let's just add our database query in of how we're going to return this. So all we've got is a query that runs and it deletes it from a table, and then I return just the input object. Usually when you return a value, you're probably best off reading from the DB at this point. I've just read out from basically the data that's passed in, because it's a simple way of doing it. But ultimately you want to double check if it's in actually the database. So now we've added that, what we need to do is go to our patient, and we can add a convenience method that allows us to discharge. And now we need a resolve of how we're going to do this. So again, it follows a similar pattern. It's on the context, it's on a patient, and it's a method called discharge, and we're passing in the input, and that's the input that we feed in about the information, the patient that's getting discharged. So once we've done that, we've got to add that to our schema. So we can add that to our schema here. So as you can see, now we have a mutation and we have a discharge patient, and that marries up to the same naming convention that is in the actual schema GraphQL. So now in theory, if we go back to our application, so John Snow is on that ward, so let's go back to our editor, and let's actually refresh this, and let's discharge. So this is how we write it. There's an input type, and it's just an object, and we feed in various of the fields that we're interested in, and then we're going to return the encounter on the patient ID. So that is that. So if we go back to our UI, if we refresh, Jon Snow is no longer there anymore, he's discharged. So essentially that's mutations. They're very similar, as you can see, to queries. They're pretty easy to set up. But there's one problem, which I don't know if anyone's noticed yet, is that this is one of the caveats with GraphQL. Is if you implement it in a very naive way with your associations, your queries are pretty horrible and you'll hit the database multiple times. So for example, I'm going to clear this out of here in this console. I didn't want to do that, I wanted to clear it. So let me run this again. Now, if we go back to our UI, and if I was to request this page again, Jon Snow's back because the database rebuilds every time. So, but have a look at this query that keeps running. So I have one query to get the patient information, and then I have one query to get the ward. But how many times do I call the same query over and over again for each patient? And that's because we have a nested association. And one of the big problems is if you don't think about how you're going to design your system up front, your nested associations will run very, very slow because you don't know how people are going to use your API. And this is one of the things that people say about, is GraphQL going to improve the performance of your system? If anything, it'll make it slower than your REST API or any API that you put in, because generally you'll have a fixed endpoint and that'll do some data and return a fixed data set. But because you can query in any kind of way that you expose via your API, if you don't care about your associations, you will get many n+1 queries and many-to-many queries all the time. So you have to be really cautious of this. But there is something that you can do to solve this, and it's called data loader. And data loader is a concept which exists in most GraphQL implementations. The one I'm going to use is a JavaScript one, but the idea is that in a specific event loop, it will keep track of all the IDs that you make, and it'll batch all those IDs into one. And then you can run one query instead of running multiple. So how this works in principle is this query is basically going off the patient ID. So if I could have an array of patient IDs, it'd make it a lot more efficient. So the first thing that I'm going to do is I'm going to change how the query actually runs. I've actually got a data loader is actually a package which I've already put in. So if we go to the admission, so now I'm basically feeding in a bunch of IDs and I'm using an in statement of all the IDs, and they're just comma separated instead of getting one by one. And all this is doing on the return type is basically batching up the admissions to the right person's admission and giving you an object back. That's ultimately all that does. So what we have to do though is something slightly different. We have to put our data loader in. So this is how you, on every request you want to create a new instance of data loader, because ultimately data loader does batching first, but it does caching as well. And what it means by caching is every time you make a request and you may be requesting multiple, say the same patient in that single request, it puts it in a cache so you don't have to keep hitting the database every time. And it does that by default. You can turn the cache off. So this is why we create one every time, because you don't want to share that information across everyone using your system, because if it's in a cache, they're going to get out-of-date data basically, and you don't want that. So this is how you instantiate a new data loader, and it's basically, I'm passing in a bunch of IDs. All it's going to do is it's going to look on the event loop, and when it comes to a certain period, it's going to say, okay, I'm going to have bunched all these 10 IDs or how many patients that we have, and I'm going to pass this now to this getAdmission method, which is just our convenience method to go to the database. So what we have to do though is we have to change our loader here. So we have admission. So now we're getting from admission, and we're doing admission loader, and then we're doing .load. And this .load will basically, this object is passing in the patient ID, so it's just going to group up a bunch of patient IDs. So now if we go back to our app, we should see, if I was to refresh this, nothing. No, that's not entirely correct. So let's see what I've missed. Yes. Good job someone's watching. So, if we go back to our application in terms of the server, I can now add in the missing component. Right. This is a duplicated file. So, that hasn't. Yeah, that's kind of gone wrong slightly. So let's fix that. So now what we've done, we've set the admission to point to the loaders, and that's just passed in again on the context. So let's clear this out, and let's rerun this. Now if we go back, that's much better. We have 3 queries instead of, I think, 12 or 13. So you have to be very cautious about how you structure your data. Otherwise, it'll look great for the user and they'll get the information they need, but when you're querying and your backend engineers will be like, this is worse than what we had before. And that's ultimately what we don't want to do. So let's go back to the slides. So, I've already mentioned some of the challenges that you face around GraphQL, because it's one of those technologies where it's sold with all its great assets in the sense that it can help you with efficiency and so on and so forth, but actually there's a lot of problems it does have when you're actually trying to use it in the real world. It's not as straightforward as just, okay, we can use it and it solves all our problems. It doesn't. So some of these challenges are, one of them is unpredictable execution, is what we saw when we saw the nested queries and we got the n+1. This is a challenge you have to look at up front. So I advise people to put like telemetry for your queries in, either on the back end or your resolve functions, to keep a track of what is actually going on, because ultimately you won't be able to solve any performance problems without them. And there's various tools that you can do with that. The other one is GraphQL doesn't handle file uploads. You can't do a multi-part HTTP file upload or anything like that, so don't try or don't even think about using it. It's not designed for that. Stick to any of the RPC or even REST, whatever you want to use. It won't work. GraphQL, as we've seen in one of the early things I want to show you, it posts, so it's no longer idempotent. So we don't have a concept of caching anymore. With a REST-based API, you can leverage HTTP's caching. You can use Vary, you can use headers. There's various things that you can do, or you can have cache servers like Vanish or Squiggle that sit in front that allow you to cache data. But you can't do this with GraphQL, so this causes a bit of a problem. So ultimately, there's a couple of ways around this. You use a client, and that client will cache your information as and when needed. But on the server, you have to think about how you're going to cache. Are you going to put a cache in front of your business logic, or are you going to cache at the database level? You have to think about these things, because otherwise, the problem that you're going to have is every time you're just going to hit the database, or you're going to hit your endpoint. And if data doesn't change so often, that is not really much of a benefit that you're going to get in terms of performance or anything, because you might as well stick to using a typical REST API. It doesn't really help you in that sense. And the other thing that I haven't really talked about is authentication and authorization. And ultimately, GraphQL doesn't care about this. It's not bothered. It has a context object, and you can pass the viewer or the JWT token, whatever you want, into it. But there's a video that I've got on the resource at the end from GraphQL Summit, which shows you 2 or 3 patterns of how, if you want to do authentication and authorization. I advise you to watch that, because it's taken, I think, from how the way Twitter do it. It's very informative, and there's different patterns that you can use. So I'm not going to go over that in too much detail. But as a whole, it doesn't really particularly care about it. It's a thin wrapper over your API, ultimately, what you want to expose. So what about real-time data? So now this is the second part of what I wanted to talk about. So up until this point, if we think about what we've seen, we have queries and we have mutations, and we have this very simple request and response model. We fire some data off to a server and it gives us something back. Or we fire some data off to a server and it does some sort of mutation or a side effect, and then we get some data back. But with real-time data, it's very different. We want to have like an event stream over time. So we might get a result in the next 5 minutes, or the next 20 minutes, or the next half an hour, or we get multiple ones every second. It doesn't follow the same pattern as the request and response. And one thing about GraphQL is that it's transport agnostic. You don't have to use HTTP. All the demos will be HTTP. But You can use WebSockets, and I've seen people use mutations over WebSockets. I've seen people do queries over WebSockets. You can choose any transport protocol which basically allows you to do a character data set. So that's why with GraphQL you can support real time, because it's agnostic to its transport layer. So what are some of the use cases of real-time information? So typical ones are chat. So everyone's used to things like WhatsApp, Slack, and various other bits of various other chat applications. And then we have things like notifications. So if you think about a good example is Facebook, and like people saying someone's liked your post and so on and so forth. Same with Twitter and retweets. And we have collaborative tools, which is kind of like online coding tools and things like that. And we have live feeds. So you get live feeds are simply things like if you think about the Guardian website or the BBC, and you're waiting for an important event, and it updates over time with what's the latest happening. So these are kind of the use cases that we kind of see with real-time applications. So real-time applications can be categorized into kind of two areas, and it's basically one's called pull and one's called push. So pull is a very simple scenario which we've all seen, which is basically just polling. It's part of the HTTP spec. It's been around for a long time, and it's very simple, and it can solve a lot of your problems generally. If you have an application where you know how often the data is refreshed, and it's quite cheap to query that, it's very easy to set up on the client side something to poll. You don't need anything else. That'll just work for you. You don't have to have anything fancy. It's a great solution still. It comes into play when your data is kind of, you don't know the time periods, and you maybe have an expensive query running every time. Then it's not so good of a use case. But the common one is push. So we're all used to push notifications as a whole. So people who have iPhones and Android phones, you'll see notifications from like WhatsApp and various other things. They're all based on push notifications. They push data out when something's happened. When it's an interesting event, it'll send you saying, okay, this has happened. So in GraphQL, there's actually two ways to do real-time APIs. What I want to cover is subscriptions. Live queries is kind of experimental at the moment. There's some experimental packages. If you want to talk to me afterwards about that, I can show you. I'm pointing you to the right direction of those, but that's not in the spec yet fully. So what live queries are is kind of like, it's like cheap polling ultimately. It's state-driven. So has anyone used Firebase before, or Meteor? There's reactive layers in Meteor, and Firebase has a real-time database that's ultimately, if something changes, it can fire stuff out. But the difference is between live query and subscriptions, the ultimate thing is what you have with live queries is you don't care about why that happened. If it's a change, we just want to listen to it. Where with subscriptions, it gives you the finer control, is like you understand why that happened because you have a payload of the event. You knew what the reason was for that. So they're two different scenarios and they solve kind of two different problems. So that's what subscriptions ultimately are. They're event-driven. They're not. They basically allow you to subscribe to it's like a query of data, and then over time you will get like a multiple number of events back. So we have a look at a little bit more detail what subscriptions actually are. So they're based on real-time events. So the idea that I just mentioned was, if something interesting happens, tell me about it and tell me why that happened. And ultimately the client defines the shape of the data that's pushed to it. And what we mean by that, if you think about what the query was like, a subscription is very similar. You change subscription at the top from the operator keyword, and essentially you define the data that you want when it's pushed to you. And that's ultimately what happens. So you define the data shape. Again, it's very, very similar. So that's the ultimate premise of how it actually works. Under the hood, currently, the implementations are pub-sub based. In the spec, it doesn't say you have to use pub-sub. But if you look at any of the packages available currently, generally the premise is that a lot of people are using the pub-sub pattern, or the publish-subscribe. So when do you want to use subscriptions? Because ultimately, subscriptions are for real-time data. Your application generally will not be built entirely on real-time data. Not always. Only a small part of your application potentially might be real-time that you want. For instance, you might have a screen it's in a finance system where you want to keep up with stocks, but the rest of the information in the stock itself, the address and so on and so forth, is static. That doesn't have to be real-time. So one of the use cases is when the initial query is quite expensive, but the subsequent following additions or the events that happen are small. So the incremental changes are small, so that's a very good use case of it. So a typical example in GraphQL is that you can set up a query by itself to load the data initially, and then you can set up a subscription afterwards to say, okay, just keep updating my store with this information that comes in. So that's one of the use cases. And the other one is when you actually care about stuff in ultimately real time. You want a low latency update. So for chat applications, say if you're using Slack, you don't want to wait 5 seconds for your actual message to come through. You expect it to come through in a reasonable time frame when that data is pushed. So how are they actually implemented? So on the left of this diagram, in pink, we have the typical model of what GraphQL is currently. So we have this request response, and we have a GraphQL API, and we have a domain which goes off and gets our data. So we can use queries and mutations on that side, and that's how we work with queries and mutations. But on the right, we have two new components ultimately. The first one is, because we want real-time information, we have to have some way of delivering that information. So one of the ways is we have this bidirectional transport. So the typical examples are using WebSockets, but you can use any bidirectional transport. It's not limited to WebSockets. So you need to kind of create a connection on the server as well as a client to say, okay, now we have this connection, I can tell you what's happening. And then you have the way you handle subscriptions, and so it's pub/sub based. There's the one I'm going to use is an in-memory collection, so never use that in live because it'll fall over completely. It's not designed for scale, but for demo purposes, it's perfect. But in the real world, you want to use something like Kafka, Redis, or MQQT, and then we have our events. So the structure of what happens is that, for instance, when we have a mutation, say when our patient wants to be discharged, we might want to update our UI to say remove them from the list because it's a real-time patient ward. We don't want to see them on the list anymore because it's not valid. So in our mutation, that's an event that we care about. We will basically say, okay, publish the fact that we've actually done something, and this patient has been discharged. So now, whoever subscribed, tell them about that and pass them the information they've asked for. And that's ultimately how it works. So this is the architecture basically from a JavaScript point of view. These are some of the packages that are available. So on the client, you can use the same subscriptions transport, which is a WebSocket. It works with just plain old vanilla JavaScript, Relay, and Apollo client. In the middle, we have the actual server. So you have your same transport layer, and then you have the subscriptions. So I'm going to use an in-memory package, which is the GraphQL Subscriptions one, which is pub/sub based, but there's Redis, there's Postgres and Mongo still not implemented, but there's Kafka, there's MQQT, there's a few other ones. There's quite a few that are now currently, and then you have your reference implementation. And this is generally how the structure is. So what you can do is, and we'll see later in the client, is you will have, when you're on the client, you set up two levels of transport. You set one for HTTP, which follows our queries and mutations, and then we have our subscriptions, which run over WebSockets. And we'll go into that in a minute. So let's have a look at another example, just to kind of like hammer home the point. So imagine we go back to our UI. At the top, we have our patient view, and there's a discharge button now, which currently doesn't exist. But on another screen, a nurse on a ward actually has a view of the ward up. And once you load that page, you said, okay, I want to subscribe to any patient discharge events. So what happens is someone elsewhere in the hospital discharges the patient, so they'll click on the button, and then we run the mutation as normal on the server. But the mutation itself actually triggers a subscription. It says, okay, this has actually happened. This is who it's happened for and why. I'm going to send you this information. And what happens is it will discharge the patient, so we no longer see the actual patient at the bottom anymore. And this is a general high-level view of how it works. We'll see, in principle, the change that we need to make from a code perspective of how it works, but this is generally how subscriptions work currently. So if we go to our demo now, what I'm going to do is I'm going to add the subscriptions in now. So the first thing that we have to do, like with any of this, so let's close all this to make it a bit clearer, is in our schema we have to define our subscription. So now what we have on our schema we have queries, mutations, our subscriptions, and we have this concept of a subscription called patient discharged, and we have this ward code about which ward they're discharged from. This is going to be very important in a minute, and I'll explain why. And then we have the event that we care about, and that is just here. All I've got is basically I'm going to return back the encounter ID, I'm going to return back the patient ID, and that's all we have. So that's how we do our schema, but in the same way we have to change our mutation. So we no longer just basically remove the patient. So now this mutation is slightly updated. So I'm going to quickly whiz through this because we're nearly out of time. We are out of time, but I'll quickly whiz through this. So essentially we have this discharge patient, and what we have is our pub/sub, and this is the return type of what comes back is what we're going to send. to our basically our subscribers. So if we go have a look in our subscriptions, let's actually first put our resolver function in. So again, our resolve function, I'm going to have to go through this quickly, is that we have this pub-sum, it's an iterator, and the topic we care about is a discharged, and we have basically if it's this ward code, because you don't want to send it to just any old user, you want to send it to the people who've subscribed by that ward, because you don't want to send it to ward 23 because that patient doesn't exist on there. So that's how you set the subscription up in terms of its resolve function. Then we still have to update our resolve mapper. And essentially I've just added the subscription patient discharged there. And now our subscription uses this pub sub framework. So the built-in memory one is just basically we have this topic that says patient discharged and we do this pub sub. So now if we just go back to our UI for a second. Yeah, all we have to do is change our server to support. So I've updated this server file, and ultimately there's a new subscription server, and this runs off WebSockets. So I'm going to go through this quickly, but all this code is available on GitHub, so anyone who wants to go through it can. So that's ultimately how you set the server up. So from a client's perspective, all we have to do is add in our query for our subscription. Actually, we'll change our client first. So our client supports both WebSockets as well as HTTP. So now we have a WebSockets client here. And then if we go to queries, we can add our query in, which is basically how we set up a subscription, where it's very similar to a query. What we want to return is the encounter and the patient ID. And now all we have to do is in our ward view is register that subscription, and this is how you register a subscription. It's just like a query. So we have our normal query at the top, and then we set up our subscription where we can subscribe to one or more events, and all we're going to do is remove from the list basically the entry that's there. So in theory, if this has all worked, if I reset this and I was to go to the discharge, it's discharged, and oops, the user's gone, and if we just refresh, they won't exist. Oh, they will, because the database is rebuilt, unfortunately. But I just want to show you quickly the subscription. So you can look in the frames, you will see actually how the subscription is set up and the life cycle of a subscription. So we can see it's in its payload and it's subscribed. And that's generally a very quick overview of how to set up subscriptions, because we kind of run out of time. So one last thing is that you can enrich your payload. Each resolver that you can use for subscription, you can change your payload, the return type that you get back. This is an advanced scenario. I probably haven't used it in anything useful yet, but if you ever need to change a payload that comes back, you can do, which is pretty useful. And there's no such thing as a free lunch, because subscriptions are stateful, and managing state is hard. You can't just scale your server like you would with an API and put another web server in and put behind your load balance and off you go, because you have connections, long-lived connections between your clients and the messages that we're sending, so you have to manage that. So you need to think about distributed load. And then you have quality of service. At scale, how are you going to manage the number of events that come through, which take priority? If you think of an example like Facebook, they have millions of likes and they use subscriptions and they use the same platform. What takes precedence? How many messages come through? How big is the wire that can come through? Can the client actually handle them? So you have to think about throttling and buffering and how you're going to organize your events. And then these are some of the resources. The authentication one's at the bottom. The Lee Byron one, if anyone wants to learn more about subscriptions, the event emitter of how it actually works. It's an event system. Definitely go watch that. The slides will be up. I'll repost them all on Twitter. And unfortunately, we did run out of time with that. But anything else, thank you, and just ask me afterwards.